Welcome to the Duck Dive. Today, we're getting into a framework that really kind of pushes the boundaries on how we think about reality.
Yeah, the source material we have is fascinating. It's called Fox's Quantum Geometry of Information Model, developed by Travis M. Fox, with, interestingly, some key technical input from an AI collaborator, Aura.
An AI collaborator, right. Yeah. And it's not just tweaking things, is it? This model starts somewhere completely different.
Oh, absolutely. It's pretty radical. The main idea, the really core premise,
is that space-time itself, the whole fabric of space and time, gravity, all that, it doesn't come from some, smooth, continuous background like we usually picture.
Exactly. Instead, this model argues that space-time actually emerges. It's built up from these fundamental, discrete units of information.
So information isn't just in the universe.
Right, it is the universe, fundamentally, or at least the foundation from which space-time itself is constructed.
Information as the ultimate Lego brick. Kind of. Okay, so our mission for this deep dive is to unpack this framework. It sounds technical.
It is a bit, yeah.
We want to understand how it builds space-time from these info pieces and, grasp the vision it offers about reality.
And we'll guide you through it. We'll focus on the key ideas, the mechanics, and those sort of aha moments where you see how information could become geometry.
Okay, let's set the stage then. Traditional physics, like general relativity, it usually starts with a continuous space-time, right? A smooth manifold.
Precisely. Think of it like a perfectly smooth rubber sheet. Points in space, moments in time, they're just coordinates on this unbroken surface.
And particles, fields, they exist on this background. Information is carried by them.
But the background itself is assumed to be fundamental, continuous.
But this model just flips that on its head. The foundation here, the source says, isn't continuous space at all.
Nope, it's these discrete chunks of information.
So information is primary, not secondary to space and time. It is the bedrock.
That's the crucial first step to get, the main departure.
All right, so if information's the bedrock, what are the actual bricks? The model calls them FUI's fundamental units of information.
Mm-hmm. And crucially, they're not just static bits, like zeros and ones sitting there. The source describes them as dynamic, active entities.
Dynamic, and with quantized properties. Quantized meaning, like specific amounts, discrete levels.
Exactly that. Like energy levels in an atom, they come in specific packets. So each FUI has a few key properties, all quantized. First, energy, E.
Okay, a discrete amount of energy. That makes sense. It contributes to the overall energy of space-time.
Right. Then there's spin. Yeah. And quantum spin, it affects how they interact directionally, rotationally.
Got it. Energy, spin.
What about location? The source position, X, Y, Z, but how does that work if space itself isn't fundamental yet?
That's a really key point. It's described as an effective position. It's not a fixed coordinate on some pre-existing grid.
So it's not like pinning a location on a map that's already there.
No. Its position emerges dynamically. It's defined by its interactions and relationships with other FUIs. The position itself is an emergent property.
Okay, that fits the theme. Emergent position from interactions. What else? Entanglement is listed, and this is huge in the model. Entanglement isn't just something that happens within space-time. Here, it's presented as a fundamental building block of space-time.
Wow. So the spooky action at a distance is actually part of the construction crew.
You could say that. These non-local connections are apparently vital for the coherence and structure of the emergent geometry. It's baked in from the start.
So entanglement isn't just a weird feature. It's a necessary ingredient for reality in this picture.
Okay.
And the last property listed is information state.
Yes. This is unique to each FUI. It's like its intrinsic data signature, almost a generalized quantum state. It dictates what kinds of interactions it can have, its specific role in building the whole structure.
Yeah, its contribution to the geometry, essentially.
Yeah.
So these FUIs, dynamic packets with quantized energy, spin, an interaction-based position, entanglement links, and a unique info state. That's the starting kit.
That's the kit. And the geometry and dynamics we experience, like space curving and time flowing, they emerge from how vast numbers of these FUIs behave and interact collectively.
Right, the collective behavior. And this is where, as you mentioned, the model gets really interesting about dimensions. It talks about a locally varying number of dimensions.
Yeah, that's a significant departure. We usually think of space-time as, 3 space plus 1 time dimension everywhere, always.
4 dimensions, fixed. But this model says maybe not.
It suggests the number of dimensions might not be constant across space. It could fluctuate locally.
How do a bunch of interacting information units decide, okay, we need 5 dimensions over here, but only 3 over there?
Well, the source introduces this idea of a local space-time value. Let's call it LBP. It's a value calculated from the collective properties of the FUIs in a particular region.
Collective properties like their energy density, spin patterns, entanglement.
All of that. The energy, the spin configurations, how entangled they are, even their specific information states. They all contribute to this local LP value for that patch of FUIs.
And this LP value, it tells you the dimensionality.
According to the model, yes. L and P dictates both the local number of dimensions and the local curvature.
Whoa. So if you have a dense cluster of highly energetic, super entangled FUIs,
that region might manifest as having effectively more dimensions or much stronger curvature compared to a sparse region with less interaction.
so the very fabric of reality, its shape, its dimension count isn't fixed, but it's dynamic. It reflects the local state of these underlying information units. That's a different picture entirely.
It is. It suggests things physicists talk about, like localized extra dimensions or perhaps compactification, might just naturally arise from how these FUIs configure themselves.
Okay, so we have the building blocks, FUIs, and how their collective state can define local geometry, maybe even dimensions. But what makes anything happen? What drives the dynamics, the evolution?
Entropy. The sources are clear on this. Entropy is the engine driving the dynamics in this model.
Entropy usually means tendency towards disorder, right? The second law of thermodynamics.
Exactly. But here, it's specified to two types. First, there's conceptual entropy, H.
Conceptual entropy.
Yeah, it measures the disorder or, let's say, unpredictability within the informational content of the FUI states themselves. Like, how messy is the data inside each unit?
Okay, disorder of the information content. And the second type?
That's information entropy. This measures the uncertainty in their arrangement and interaction patterns. How messy is the structure they form? How unpredictable are their connections?
So disorder in the content and disorder in the structure makes sense.
Right. And the total entropy, T, is just the sum. T equals H plus IA.
Okay.
And the model states that the evolution of this informational spacetime is driven by the tendency for this total entropy to increase. That's the second law acting as the driving force.
The universe just wants to maximize the total messiness, both internally in the FUIs and in how they're arranged.
That seems to be the engine, yes.
So where does time fit in if everything's driven by entropy increasing?
Time itself isn't fundamental either in this model. It's not a pre-existing line. Things move along. It also emerges.
Emerges from the entropy increase.
Precisely. Time is essentially the sequence of changes in the FUI configurations and their interactions. Each change, each rearrangement is propelled by this drive to increase total entropy. So a tick of emergent time corresponds to one of these fundamental FUI reshuffles or interaction events.
Time is the unfolding process of information optimizing its entropy state.
That's a good way to put it. It really places information evolution at the absolute core of reality.
Okay, so geometry emerges, time emerges. How do we get back to things like gravity and curvature that we experience? How does the model generate those?
Also derived from the FUI's collective state. The space-time metric, the mathematical object M in general relativity that defines distances and tells space how to curve.
Yeah.
That's not fundamental here. It emerges from the FUI properties.
Terrifically.
The source suggests the collective energy density from the FUIs in a region, their spin configurations, their entanglement patterns. These all contribute to determining the components of this emergent metric tensor.
So it's like in GR where mass energy tells space-time how to curve.
Exactly. But here, it's the concentrated properties within the FUIs that directly generate the emergent curvature we perceive as gravity.
Gravity isn't a separate force field then, but just the large-scale effect of the underlying information structure's state.
An emergent geometric effect, precisely. And the same goes for the connections, the Christoffel symbols.
Those define how things move, like shortest paths, geodesics.
Right. They describe how vectors get transported across this emergent curved space. And they also emerge arising from how the FUI configurations and their internal states change from point to point, effectively defining the flow within the FUI-generated geometry.
It feels very self-contained, everything building up from these FUIs and their interactions, driven by entropy. Okay, this is a pretty radical framework. What about the big unanswered questions in physics? Does this model offer any new angles? The sources mentioned a few.
It does suggest some potential new perspectives. Take singularities, the infinite densities predicted by GR at the Big Bang, or inside black holes where the math breaks down.
Yeah, infinities are usually a sign something's wrong or incomplete.
Well, a model built on discrete information units, FUIs, might naturally avoid infinities. Instead of infinite density, you might hit a maximum possible information density determined by the FUIs themselves, a discrete limit.
That could resolve the singularity problem. Interesting. What about dark matter and dark energy?
The idea here is that perhaps some FUIs or specific configurations of them interact gravitationally, contributing to the emergent curvature, but don't interact much or at all via electromagnetism.
So they'd be dark to us.
Potentially. Their properties, maybe related to specific entanglement structures or information states, could warp space-time or drive expansion without emitting light or interacting like normal matter. They'd be part of the informational fabric's influence, just not a visible part.
The dark sector as just different types or states of FUIs, and the big one, quantum gravity, unifying QM and GR.
This model is inherently trying to do that, in a way.
Right.
It starts with quantum-like properties, quantized energy, spin, entanglement at the FUI level.
And builds the large-scale space-time geometry of GR from those quantum foundations.
Exactly. Gravity isn't being quantized directly. It's emerging from an underlying quantum informational system. It offers a potential path.
And the black hole information paradox. Does information really get destroyed?
If information at the FUI level is truly fundamental and conserved as this model posits,
Then maybe it can't be destroyed.
that's the hope. The information might persist in the underlying FUI structure, even if the emergent spacetime description makes it look like it's lost inside the black hole. It could offer a different angle on the paradox.
Stepping back, the overarching vision here is pretty mind-bending. Information isn't just something in reality, it is reality's fundamental substance. Space-time is woven from it.
It really forces a rethink about what's fundamental. Is it space, energy, or is it information?
And exploring this, you can see how it might provide completely new ways to approach those really tough, persistent questions in fundamental physics.
It's definitely a complex theoretical landscape, but yeah, fascinating one.
So, for you listening, what this offers is, well, a glimpse into some really frontier thinking. How physics, sometimes even aided by AI now, is questioning the very basis of space and time.
It presents this picture where the reality you experience, the geometry, the flow of time, it might all be an emergent show put on by the collective dance of these tiny fundamental units of information.
A universe literally made of dynamic data. And maybe this leaves us with a final thought to chew on, something from the source material itself. If space-time, gravity, maybe even dimensions are all just emergent phenomena arising from how these FUIs interact, what does that really tell us about the nature of information itself?
Is it truly the most fundamental thing? More basic than energy or matter?
And think about this. If space-time is just one possible large-scale structure that can emerge from the collective behavior of these informational units?
What else might be possible?
Right. Could there be other completely different kinds of emergent phenomena, maybe structures or dynamics we haven't even conceived of yet, just waiting to be discovered in the complex interplay of all this fundamental information?
Definitely gives you a lot to ponder about what reality might be built on.
It certainly does. Thank you for joining us on this deep dive into the quantum geometry of information.